All right, I'm going to present the last part of our solving systems of equations foldable notes. We have done our graphing to solve systems and looked for the point of intersection, and we've done our substitution to solve systems where we solve for one variable and then use it to find the other variable. And our last method that we're going to look at is elimination for solving systems. Now, before I begin with the problems for elimination, we're going to do, I believe there's 3 of them. Yeah, we've got example 5 and 6 and then example 7. Get your foldable ready so like it's all good and creased and you can do your work along with me. With the elimination method, there's a couple things that are going to come into play. We're going to almost look at our system of equations as if they're stacked with like terms on top of each other. And if you look, we do have like terms on top of each other in example 5. The 4x and minus 2x, I know they're in 2 different equations, but they're like. And then positive 3y, or I'm sorry, negative 3y and positive 3y, those are like terms as well. And then the 5 and 7 don't have x or y or any variable on them, so we could combine those. And the object of the game is, in solving a linear system using the elimination method, is going to be to try to combine the 2 equations by adding them together, like literally adding together the x's and the y's down, and the x's down and the y's down, and then your constants down, and bringing our equal sign down, with the intent to get rid of a variable, because we struggle to, we have to have methods, because if we have an x and a y, we can't just figure out what the x and the y are without doing some algebra. If we can reduce it to having just one variable to solve for, we'll be all set. So it's going to get more complicated with our algebra. We're going to fall back on some of the basics that we know. Now, if I look at what I have here, I know I can use elimination. I've had experience with this, but I'm also looking at the fact that negative 3y and positive 3y together are going to go away. Negative 3y and positive 3y are going to make 0 if I combine them. So if I can make that go away by doing 4x minus 2x, I'm going to get 2x. And 5 minus 7, I'm going to get negative 2. I'm down to solving simply for x. I eliminated the y variable from both the equations. I can focus on just solving for my x. And like we did with substitution, cool, x is 1. Like we did with substitution, I don't want my equations buried too bad in here. I can go back now. Let me grab that one. And I can plug in negative 1 for x, and it'll help me figure out y. So let me do that second part. I know my x is negative 1. All right, so 4 times negative 1 minus 3y is equal to 5. Now that I know an x value to put in, I can solve for y. The only variable in this equation at this point is my y. 4 times negative 1 is negative 4, minus 3y equals 5, and we're just undoing in order to get y alone. This may be a video that you want to look back at a couple times, because this particular example was set up nice and neat for us to use elimination because of that opposite of the negative 3y and the positive 3y. And I'm just finishing up by dividing by negative 3. So I'm finding out that y is going to be negative 3. So my solution to this system is the ordered pair negative 1 and negative 3. Now, when we go to example number 6, one of the things that I want you to notice is that we've got the terms that we could combine stacked on top of each other like we had in the other one. 7x, 7x. If I put those together, that's going to give me 14 x's. It's not going to eliminate an x. Negative 2y and negative 3y is going to give me negative 5y. That's not going to eliminate a y. But in the method of using elimination, we've got to remember that we can make changes to an equation if we multiply the equation or divide the equation by the same thing on both sides. Now, the reason I say that is because, man, if I could just have this be negative 7x, I could combine these 2 equations for that elimination method. And so what we do is we actually do the work and say, you know what, I want that to be negative 7x. I'm going to multiply everything in this equation by negative 1. And I got to do that on both sides. That's going to be multiplied by negative 1. Now, I'm going to come over here. I'm going to rewrite my top equation the same way it was. 7x minus 2y equals 5. I'm just rewriting this one. Now, if I multiply this whole bottom equation by negative 1, I'm going to wind up with negative 7x plus 3y equals negative 4. I just did something to effectively eliminate the x's to solve That's going to leave me with nothing. Now look how this plays out right here. Negative 2y and positive 3y. Y is equal to 5 minus 4, 1. I eliminated that. I altered the equation by I wanted 7x to be the opposite of 7x, so I used negative 1 to get there. Now I know y is 1. Just like we did in our other equations, I've got to go back and use my y now. 7 times x minus 2. I'm grabbing the first equation to figure out what the x value is. And I'm going to get 7x minus 2 equals 5. If I add 2 to both sides, add 2, 7x equals 7, divide by 7 on both sides, divide by 7, x is equal to 1. So actually the solution to this system is 1, 1. Going to circle that final answer. I have a feeling you might have missed this. When I plugged it in, didn't move my paper, sorry about that. I plugged in 1 for y, did the math, added 2 to undo the minus 2, got to here, divided by 7, and got x is 1. Had my y was 1, used it in the first equation. Cool, sorry I wanted to back up there. I didn't realize you weren't watching me do that. Last example. If you look at example 7 now, kind of like, oh, nuts, neither the x's are opposites of each other to start, the y's aren't opposite of each other to start, but I'm thinking that if I could simply multiply this equation, if I could get this x to be a negative 4x, I could make that go away. So I'm going to use the same idea I did in the last one. Why don't I do that? Why don't I multiply this side by negative 4 to get what I want? As long as I multiply by negative 4 on this side, I got no issue. I'm going to rewrite my system. 4x plus 3y equals 8. Negative 4x plus 8y equals, 13 times negative 4, it's going to be negative 52. All right, so I multiplied by negative 4. The object of the game was to try to get an opposite coefficient on the x. And remember, a coefficient is a number that's stuck to x. Did what I wanted. Got nothing there now. 0. The 4x minus 4x is giving me 0. I've got 11 y's. Now, 8 minus 52. Let's see, I have $8, and I loan you 52. Well, if it was 8, let's see, if it was 8 minus 50, I think I would be at negative, where am I going to be? Negative 44, I believe. I'm positive 8 minus 52. Yeah, I'm pretty sure it's negative 44. I'm going to finish up and solve for y by dividing by 11. Y is going to be negative 4. Now I have to go back and use it. I'm going to go back to my first equation. My first equation is 4x plus 3. Let me plug in that y value I had. Equal to 8. Do my math. 4x minus 12 equals 8. Add 12 to both sides. Add 12 to both sides. 4x equals 20. Divide by 4 on both sides. X is 5. So the solution to this system would be 5, negative 4. Cool. Revisit this video. This is a pretty tricky method, and there's a lot of algebra going on that you have to practice and get real good at. Good luck.